All right. People want me to do oxidation and reduction on alcohol, and we will use. Okay, people. Your question was, where is this one come from, right? Before we actually write. Okay, where is this one come from? That's your question, right?
Yeah.
Where is this one come from? Okay. Okay.
Just looking at that, like this part.
Okay. Okay. How is this one come from? It's okay. You find a alkane. That's a alkane, right? And then the metal we use here is lithium. Have you ever seen those? It's part of your Gen Chem. That's in Gen Chem we say, okay, the first column is really reactive, right? Didn't we kind of like say that? Okay, that's why it's we only choose certain metals. If you still remember on the notes, we only choose certain. Either you are seeing lithium or you are seeing specific the magnesium. Let's say lithium is the only one that you are going to know for this part. The metal that you are using so far, you've seen so far, lithium, and MgX. Okay, that's after it's being formed. This will be the only two. But your question is about this. We'll talk about Grignard later. Okay, when lithium is reacting with this, okay, we want you to form. Okay, the reaction I showed there is, okay, with lithium, because it's a kind of like a, okay, let me compare this way. Lithium will take positive no matter what, right? You kind of like, when you combine those, you are forcing the R to be minus. Usually we see carbocations, but this one is a carbon, okay? Previously it was something like this. Previously was CH3. In our case, our lithium is positive. Then the only one who can take a negative will be this carbon.
And lithium is like being forced to bond there.
Yeah.
Okay, got it. Okay, so that's why you had the 2 electrons there.
Okay, and then think about the two. Think about the two. This one will kind of like have a hydrogen 4 off, right? And then we need 2 of that to make hydrogen gas. Are we good? It's not commonly seen. It's only because they're so reactive, and the only way they can react is become positive. Then this one just like your R group has to take negative.
And that's why the reaction starts with like carbanion.
Let me just say one more. In your 118b, okay? In your 118b, you are going to see a very similar case. That's mercury is a metal. There will be a mechanism with this. It will be a very similar case. Usually, you will see a lot of the time carbon is positive. You will see a lot of the time carbon is positive. In your 118b, you are going to see a case, okay, because I'm a metal, I will take a positive and the carbon cannot. It will be very similar to this. It's a different mechanism in 118b. But just like, remember I pin you here. When you have a metal, only the metal take positive. Carbon can take a negative or can take neutral. But once you have a metal there, you should leave that positive to metal, no matter what. Yes?
And so is this reaction starting with the carbocation already present, or are we assuming that you began with all 3 hydrogens and then reduced?
This one or this one?
For the one with lithium.
This one, you start with alkane, neutral. Okay. Yeah. And you end with a negative. Okay. This one, you start with carbocation. You end with mercury is grab that's positive. Okay. So you will see very similar case in the future.
Is this just the acid base stuff?
Which one?
Like this is Grignard, right?
This one is okay. Grignard, we specifically change this metal into magnesium, and because magnesium is 2+, so people need a X minus. This will be Grignard. This is Grignard. Grignard is only this one. Are we good? Are we good? Are we good? But it works the same way. It works the same way. All we care is your R minus. All right?